So once you know how to factor, then you can begin the solving part. And so just remember, solving is if you had x squared plus 5x plus 6, and you set up your x, sum to 5, product of 6, you get x plus 2 and x plus 3. Those are your factors, but if it equaled 0, you would have one more step, and that's that x plus 2 could equal 0 or x plus 3 could equal 0. So x could actually equal -2 or -3. And so that's what we're jumping into today. You didn't have to write that down. So if I ask you, what are the zeros? Well, this is already factored for you. So if I set that piece equal to 0 and that piece equal to 0 and that piece equal to 0, over here, x plus 2, subtract 2, x could be -2. For this piece, I would add 1, so x could be +1. And for this piece, add 3, and x could be 3. And that's how you find the zeros. It's nice when it's already factored. Over here, what if I said roots? Well, remember, zeros mean the same thing as roots. So zeros, roots, x-intercepts, all those words mean the same thing, which sometimes is just represented as solve. So for this one, when it asks you what are the roots of g of x, well, it's already factored, so you just need to look at each piece. So roots, zeros, just pretend that equals 0. So x could be 0, add 3, x could be 3. Over here, subtract 5, x could be -5, and that's it. Now for this one, it says, what is the intercept form? Well, remember, if you factor it, and then you set each piece equal to 0, the x-intercepts, that is just the opposite of the factor. So basically, if you see intercept form, that's just a fancy way of saying factor it. So for this one, factor it, put it in intercept form, and then what are the x-intercepts? What are the multiplicities? And we'll get to that. That's the linear quadratic in just a second. So if I factor this, I could take an x out, and then I'm left with x squared minus 4x plus 4, which hopefully you recognize as a PST, because if I square root that and I square root that, I get x and 2. 2x doubled is 4x. So that's going to factor to x, and then it's going to be x minus 2 parentheses squared. And you can set up your x and do your sum and your product if you need to, but if you're recognizing those shortcuts, that's a lot better. So that's intercept form or factored form right here. Sometimes you'll see intercept form, sometimes you'll see factored form, same thing. So then the question is, well, what are the x-intercepts, which you could just rewrite as zeros. So remember, this part could equal 0, or that part could equal 0. So x could be 0 or x could be +2. And then it says, what are the multiplicities? And this goes back to the linear quadratic stuff that we've been talking about. So this factor was linear, so that multiplicity would be 1. This factor was quadratic because x minus 2 equaled 0, but technically you had 2 of them. So if it's quadratic, that just means it has a multiplicity of 2, and that's it. So for multiplicity, I can just say multiplicity is 1, and for that, I could just say the multiplicity is 2. So just remember, linear, automatic multiplicity of 1, quadratic, automatic multiplicity of 2, maybe you have something cubed, multiplicity of 3, and that's it. So on this one, if I said factor it, well, I see x to the 4th, x cubed, x squared. So I'm going to start by taking out x squared. And then I'm left with x squared minus 2x minus 8. Set up my x, sum to -2. Product is -8. I'll give you a second to think of them. Get -4 and +2. Okay, now because a is 1, I can just shortcut and just rewrite it as x minus 4 times x plus 2. Only because a is 1. And then automatically, boom, already in intercept form right there. Now, what are the solutions? Well, x squared could equal 0, which is just like saying x could equal 0. X minus 4 could equal 0. X plus 2 could equal 0. So when I do all of that, the first one I get 0, and then I get add 4, so positive 4, and then subtract 2, so negative 2. So I get 0, 4, negative 2. Well, what are the multiplicities? Well, that was squared, quadratic, so that has a multiplicity of 2. 4 has a multiplicity of 1 because it was linear. And negative 2 has a multiplicity of 1 because it was linear as well. And that's it. If you can factor it, then you can solve it and you can state what the multiplicities are. The factoring part is just getting it into that form where it's a lot more clear to see. Now, if it tells you what the zeros are, so I have negative 2, 2, and 3, and I want it in standard form, now I'm going backwards. Now it wants it in that form. Which means if one of the zeros is negative 2, then that would factor to x plus 2. If one of your zeros is positive 2, then that would factor to x minus 2. And if one of your zeros is 3, that would factor to x minus 3. Now, what I currently have right now is intercept form. They're all factored. It's all nice and neat. Remember, intercept form is the same thing as factored form, but the problem's asking you for standard form, which means it doesn't want it separated out like this. You have to distribute everything out. So you can do box method however you want to multiply it. I'm going to do the lines because that's just what I like. So if I start distributing, x times x is x squared. X times negative 2 is negative 2x. 2 times x is 2x. And 2 times negative 2 is negative 4. And maybe you caught that it was a difference of squares, so you can just jump straight to x squared minus 4. But I have to distribute everything. So I've distributed this. I have not distributed this yet. So now I have x squared minus 4 times x minus 3. And now I'm going to distribute all of that out. So x squared times x becomes x cubed. X squared times negative 3 is negative 3x squared. Negative 4 times x is negative 4x. And a negative 4 and a negative 3 make positive 12. And just say y equals, and there we're in standard form. So standard form, you have to distribute. Intercept form or factored form, you don't. So it just depends on what is the problem asking you for. Are you going forwards or are you going backwards? So if I take a look at this one, I see my zeros are negative 2, negative 2. Because that appears twice, that means it has a multiplicity of 2. Which means when I go to write that factor, it's x plus 2, but it's x plus 2 squared, because it's 2 of them. Positive 2 means that one of my factors is the opposite, x minus 2. And then my other factor, positive 3, so the factor opposite would be x minus 3. And now I have to multiply all of this out. So what I'm going to do is, I know x plus 2 squared is a PST. So that's going to be x squared plus 4x plus 4 times x minus 2. And then I'm going to multiply the x minus 3. You could multiply that and then multiply those and have a trinomial times a trinomial, just as long as you're distributing everything out and being really careful. So x squared plus 4x plus 4 times x squared minus 2. Coming over here where I have a little bit more room. And now I'm just going to distribute everything out. So x times all of this becomes x cubed plus 4x squared plus 4x, essentially just adding an x. The negative 2 is going to change all those signs. So I get negative 2x squared, negative 8x, negative 8. And then combine like terms, so I get x cubed plus 2x squared minus 4x minus 8, just like that. And if I made a silly mistake and I haven't caught it, just forgive me. Hopefully I haven't. And I'm going to multiply that by x minus 2. Okay, now notice it says intercept form. So you could have just stopped right here. and left it at that. But if it said standard form, you would have to distribute it. And just because I didn't catch that and we're already here, we're just going to keep going. So x cubed times x is x to the fourth plus 2x cubed minus 4x squared minus 8x. And when I distribute the negative 2, I get negative 2x cubed minus 4x squared plus 8x minus 8. What happens is a lot of things cancel out. And I get x to the fourth minus 8x squared minus 8. Now notice that's standard form. It did say intercept form because you could just stop right there. But I will warn you, on the quiz and on the test, you're going to see it in standard form. So make sure you know how to distribute everything all the way out. Okay, now this next one is unique because it's x equals 1 and I have a plus or minus 3i. Which if we go back to complex numbers, that means that one of your zeros was technically plus or minus 3 times the square root of negative 1. And so I'm going to give you a chance to just refresh yourself on complex numbers, and we'll jump back in on this problem in the next video.